DJ Patil has held a variety of roles in academia, industry, and government. Most recently, he was appointed by President Obama to be the first US chief data scientist, where his efforts led to the establishment of nearly 40 chief data officer roles across the federal government. He also established new healthcare programs, including the Precision Medicine Initiative and the Cancer Moonshoot, new criminal justice reforms, including the Data-Driven Justice and Police Data Initiatives for more than 94 million Americans, as well as leading the national data efforts. He also has been active in national security and, for his efforts, was awarded by Secretary Carter the Department of Defense Medal for Distinguished Public Service, the highest honor this department bestows on a civilian. In industry, he led the product teams at Relate IQ, which was acquired by Salesforce. He was the founding board member for Crisis Text Line, which works to use new technologies to provide on-demand mental and crisis support, and was member of the venture firm Greylock Partners. He was also the chief scientist, chief security officer, and head of analytics and data product teams at the LinkedIn Corporation, where he co-coined the term data scientist. He has also held a number of roles at Skype, PayPal, and eBay. As a member of the faculty at the University of Maryland, his research focused on nonlinear dynamics and chaos theory, and he helped start a major research initiative on numerical weather prediction. As an AAAS Science and Technology Policy Fellow for the Department of Defense, Dr. Patil directed new efforts to leverage social network analysis and the melding of computational and social sciences to anticipate emerging threats to the US. He has also co-chaired a major review of US efforts to prevent bioweapons proliferation in Central Asia and co-founded the Iraqi Virtual Science Library. In 2014, he was selected by the World Economic Forum as a young global leader and is also a member of the Council of Foreign Relations. Finally, he's also a fascinating person, and we are all in for a treat today. Ladies and gentlemen, please join me in welcome home Dr. DJ Patil. I would request Kunal to take the stage.
Awesome.
Thanks, Deepika.
Yeah. It feels like we're kind of far away. Maybe we can scoot these things forward. How do you feel about that?
Yeah.
Here, I feel like you guys are like way over there. Here, so this is like agile speaking. All right, there. That's a little bit better. Yeah,
okay.
That was kind of weird. Like we're.
No.
Okay.
Thanks, DJ, for taking time out and coming here. And I have to start with a confession. So about 2 months back, and I don't know whether you would remember this. So I actually reached out to you to invite you as a keynote for an upcoming conference which we have in November 2017. And I just wanted like anything that you come to that conference. And I think within a day of me sending out that mail to you, the reply came that you can't travel to India at that time. And I was like, oh. But little did I know at that time that he would be traveling to India soon, and then I'll have this opportunity. So thanks a lot for taking time out. It means a lot to the community and to us.
I have a huge staff that handles my email.
Okay.
It's called Me, Myself, and I.
Yeah, I can imagine.
I have no more team. It's all you're looking at the team.
No bots yet?
Pardon?
No bots doing
no bots. Nothing crazy sophisticated or anything like that.
Okay.
No, but it's just me.
Okay, great.
In the wee hours of the morning.
Sure. So DJ, how has been this trip to India, and then when was the last time you were here, and then how do you see things changing in India?
Yeah, so the last time I was here was about more than 3 years ago. Okay. Because it was definitely before the White House time, so almost 5 years ago. And there's a few companies that I've been really focused on helping in India grow over time. Is there a fair amount of static coming out to you guys over there? Yeah. Maybe we should switch. Let me try this. If I switch, say something. Is it coming? Are you getting static from your side?
Check.
Let me try that now. No, I think it's me. Is there the other mic? Let's see if that will work instead. All right, is that better? Yeah. Well, maybe it's just me. Pausing this. All right. Well, let's try this, and hopefully it'll be a bit better. So I've been fortunate to help a few companies out here in India over time, and really see how they've evolved. A few of those companies have luckily grown into something substantial. Ola Cabs, Savin, Flipkart, it's been a few of them. And it's been really amazing to come back and also see how much those companies not only have evolved in terms of the business ecosystem here in India, but more importantly, how much they've evolved in terms of the infrastructure, the technology, and the talent. Mm-hmm. You have extraordinarily the top cutting-edge type technologies here. Mm-hmm. You have incredible talent, some of which has come back from the U.S., but an increasing amount is homegrown, and so that's very exciting to see. And then what we're starting to see the inklings of, and it's very, very early, and I hope that we'll see a tremendous amount more of this, is that we'll start seeing a much more innovation in data and technology, specifically in the stack, the technical stack, that is going to be innovated and built here in India as well. So the next generation of the Storm, Kafka, Spark, these Hadoop, I'd love to see that being a more global type kind of effort by the community.
Sure, sure. So the last visit was after coining the term, but still not. It still didn't get as much attention to this time where.
Well, people were talking about it, and people had job titles about it, but it's been phenomenal to go through it. And maybe we can go through the explanation of the titles. That would be helpful.
Yeah.
So for those that don't know the story, we weren't trying at all to start a new field. That was the last thing that was on our mind. Literally what would happen is Jeff Hammerbacher, myself, and a number of other data scientists, we'd regularly trade notes. And then people think that's often surprising because we'd be in very competitive companies with each other. But the way we approached it and really thought about it was, if more water in the harbor floats, more boats. And so that was really a strong approach. So if I was working with a certain technology and I was going to open source it, I would let them know, and vice versa. We'd also compare notes of like, hey, how's the servers and the databases? Like, is that working for you? Or is that scaling? Is it performant? What are you hearing from the vendors? What works? What doesn't work? So that combination would bring us very regularly to talk about technical issues. And on this particular lunch, I brought up as one of our kind of last topics was, what are you calling yourselves? And that was because LinkedIn was getting to the point of getting near to the filing of an IPO. And so LinkedIn was getting ready for the IPO, and HR was coming to us and saying, hey, you got all these titles on there. You got analyst, research scientist, analytics, super whiz, superstar, all the different titles, and engineering has engineer, design has designer, sales has sales. So you guys got to have a title. And Jeff had the same problem. So you kind of go through the list, and you're like, analyst, well, that feels very Wall Street. Whether we like it or not. Business analyst is like, well, you're just only allowed to do dashboards. Research scientist is a little too academic. And you kind of go through the list, and you're like, well, what's a good title for us? And it's not obvious. And we're trying to figure out not only a combination of what would be least offensive, but what would be you'd be proud to have on your LinkedIn profile, because we didn't really care about business cards. We're LinkedIn. True fact. So out of that concept was, we kind of go through the list, and finally we're like, well, what's left? And you're like, data scientists. Yeah, we're kind of science-y. We all come from scientific backgrounds, and we do data scientists. But the part there, what we really found was effective is because we were LinkedIn, we posted all the jobs, and we just replaced the titles, and we subbed out the title and all the things. So One was all about analysts. One was another one about research scientists. Another one was, finally through the list, and it was data scientists. And everyone applied to the data scientist one. And all the people that we really found that had the skills that were necessary to build LinkedIn also all had applied to the data scientist one. And that was a really surprising move. So then we said, oh, okay, well, we're data scientists now. And I think what's interesting is why hasn't the term data scientist, why is data science and data scientist kind of taken off? And I literally think it's because no one has a clue what it means. If you and that's why we're all kind of here. We're like, well, what makes a good data scientist? What does this? We're all figuring it out. But here's the key, and this I've seen this happen multiple times. Is people are in a meeting, and they're like, who's that? And why are they here? And they're like, that's the data scientist. I'm like, oh, okay. Yeah, they do data science. Yeah, they must be smart. So that kind of shift, and it's surprising in this world because, if you're an engineer, somehow you're not allowed to do design. If you're sales, you can't do any front-end engineering. Why do we put ourselves in these boxes rather than asking ourselves to really figure out how we can step out of those boxes and do radically different things? That's a very big shift. And because no one actually understands what the term data scientist means, it gives us the permission to do anything you want. Because you're the data scientist. No one knows who you are and why you should be in the room, but they also don't know why you shouldn't be in the room. That's the funny part about the world we live in is we love to make people just smaller. We don't try to make the table bigger. And in all cases, the reason I think the data scientist title has stuck is because whenever you're in the room, you now have context of how to solve the problem. And so you're that much more effective in actually building solutions. And therefore, as a result, you actually make a disproportionate impact compared to everybody else. And that's why we see this different model of now people are asking, who's the data scientist in the boardroom? Which is really fascinating because there isn't an engineer in the boardroom, which is still a problem. So we need make these tables bigger rather than smaller. And that certainly was emphasized in my White House experience as well, because most people are like, well, why is there a data scientist in this room? And this is an important room. And they're like, because it's the chief data scientist. Yeah. I'm like, great. I get to be there.
And so first of all, thanks. I mean, we all have that identity now. I don't know what we would have been called if this term was not there. But was there a second nearby competent term which you were thinking at that time? And if so, what was that?
The greatest tension we actually had in terms of the titles, which is still there, is like, are you in analytics or are you in data?
Data.
And so we went around and we were trying to figure out, is our team called the analytics team or is it called the data team? And I was like, well, the data team is actually more low level and we're moving data around, and analytics is what we do on top of the data. The only people who care about that is data people and analytics people.
Correct.
The rest of the company and the rest of the organizations, they're like, those are nerds. That's the way they look at us. They're like, whatever. In the same way, we look at sales and we're like, you talk to a salesperson and you're like, look, are you one of the various end stages of sales, right? Are you the kind of opener? Are you the closer? Are you help sales support? Those are all critical roles, and we should be able to be better at defining what people do. I am all for more ambiguous roles, but more importantly, talking about what skills you bring to the table. And making sure that we always are very focused on building a team, and we ask what skills there are. In cricket or in basketball or in soccer, you don't talk about a person necessarily only being about a certain position. They may have a label of a position, but you're more focused on all the attributes of what they can actually do and how they pair with others to be effective.
Yeah. Interesting. So DJ, we see you today with this successful career, but let me kind of step back and move a bit back in time. So can you tell us about your journey and how it started? How did you come into learning your maths and that stuff? So what were the early years of education like?
So I was born here in Delhi. Actually, my aunt and cousin are here. All my credit goes to them. Also, anything I say that's stupid, blame also to them. but in all seriousness, the thing that was what happened was my father was a professor in MIT at the time, and so we moved back to MIT to really where his work was, and I grew up really in the foothills, the mountains of Utah. And in Utah, it was a phenomenal place to grow up as a kid because it was just nature everywhere, and you were just an incredible community. And one of the things people always ask is, why I don't speak Hindi or Marathi is because the only other Indian family was not so close in Utah, all of Utah. So you didn't actually have the ability to speak to anybody with the language, and I had grandparents who were helping raise, and they didn't speak English, so they learned English as a result. But I was a kind of student who was much more regularly in trouble than doing my regular work. I wasn't very disciplined, is probably a good word. And we moved to Utah, from Utah to California, where my dad started his company, Cirrus Logic. But I just continually spiraled into being a worse student. Part of the reason was I had an academic system that didn't emphasize a curiosity and didn't emphasize a love of learning. It was more focused on assignment sheets and how have you done the very precise way we do things. And so I started just doing a lot of science on my own. I was building things, learning about things. By the time I got to high school, in the first 6 weeks or a few months, I had already been suspended from school once, kicked out of my math class, had my rights read to me. So I was on a stellar trajectory. I was bombing all my math classes. I would go to summer school to take the classes. And so I didn't get into college. But I was very fortunate that I had a phenomenal, just this amazing junior college, which is a 2-year institution in the United States that basically prepares you to go on for 4-year other institutions or trains you for a vocational career. So I went there, and my girlfriend at the time, she took this class called calculus. So I took, of course, this class called calculus. And I literally was like, what are these symbols? Everything ends with a dx. They're a constant at the end of the S thing. It's kind of squiggly. And I realized I really didn't understand any of this kind of mathematics, especially for the science that I was kind of playing around and learning about on my own, like fractals and chaos theory. And so it was this very strong fork in the road where I had to decide, do I want to do more just kind of playing around or really learn the hardcore details of what's required? So I went to the local school library and I checked out all the math books and I taught myself high school math in a few days. And if you want to know something is super frustrating, is knowing that you just went through 4 years of hell in math class and then realizing you could have just gotten out of it if you decided to try for 3 days. That was an incredibly eye-opening experience. And so I very quickly went through my classes, kind of moved on very quick. I petitioned my way into acceptance at University of California, San Diego, where I just took every math class I could. I graduated with a degree in mathematics and 2 equivalent what might be considered minors or programs of concentrations in theater and psychology, and went straight to grad school. And in grad school, I went to University of Maryland to work with the guy, Jim York, who actually coined the term chaos theory, and spent my whole time just really studying there, and then eventually joined the faculty as a mathematician. But it's one of the things I think which is really important, especially in data science. Data science isn't about being smart. There's an element of smarts that you have to have in lots of different areas. But data science fundamentally is about being clever. It's about seeing nuances in problems and finding really interesting solutions that when you use different data sets in novel ways, you come up with something that you never would have expected or appreciated.
Correct.
And that the core principle that you have to do that is curiosity. Without curiosity, you can't have that. And it's one of the most beautiful things that you can start to try to instill in yourself is just a love of playing with data, a love of playing with different problems, especially given how many data sets are out there now.
Yeah. And interesting. In fact, I mean, I can relate to you coining a term in US back then, and then the kind of impact it has created, almost to the most commonly said analogy in the chaos theory that a butterfly flaps its wings and it results in storms.
It is literally that. We had no plan. Like, we had no, Jeff and I have talked about this, it's like no one expected data science to take off this way. We knew that data was going to go in this incredible next wave. And you know how the term big data came about? So big data actually, so there's this guy named Roger Margulis. And Roger is with O'Reilly Media, and he'd been saying there's a massive movement coming in data. And people need to pay attention to it. And nobody would take him seriously. So instead, he's like finally said, okay, I'm going to talk about big data. And then everyone took him seriously. So it's funny like how things just like a little change of a term take off. And if you ask them, like many of us were like, oh God, the worst thing that you could call something is big data. But it's a term that just kind of captured the imagination of people. People saw that it could do really unique things.
Got it. So coming back to your journey. So you did your graduation. When did you decide to do a specialization or a PhD in mathematics, and how did that happen? And what was the driver for that?
So I was always, the reason I started studying math is because I think math is one of the greatest foundations to learn about all subjects. Because with math, you can go into all sorts of different areas. It's just an incredible foundation. But I was doing an incredible amount of coding too. So I was just everything from, at that time, everything from Pascal to C to assembly code 6800 architectures, you name it. And then MATLAB, Mathematica, all these things. Because I was very interested in just how to play with data. So those languages offered different approaches. And so I would use all of them at various times. My true love really there was understanding how does the world function. And one of those ways that I think was very powerful at the time was chaos theory. And so I was very focused on that. And I really wanted to learn everything I could. And I thought the way to do that is by being an academic and being a professor. And so that training path is very clear cut of go get a PhD. And I tell people you should not go get a PhD unless you don't start a PhD program unless you intend to finish. And you really have to want it. It's not something you just play around and kind of go get. You have to put all your heart and love into going and getting it, and get it because you want to know a subject at an extraordinarily deep level.
Yeah. It needs that kind of commitment. Just a quick question.
Also, let me add one thing. You don't need a PhD to do data science. Let me just be super clear cut. That is like people who go do a PhD thinking like this is the best route to go get something. When I got after I'd finally had become a faculty, and then I'd gone off to the Department of Defense for a couple of years to go work on things, and then coming back, deciding whether to spin up the lab and how to figure this out. We said, well, my wife was living in New York, I was living in DC, we couldn't figure it out. We said, let's just move to Silicon Valley and something will work out, because I knew a lot of people in Silicon Valley. And it turned out nobody wanted to hire me. I talked to Google. Google's like, yeah, you seem smart, but you're a mathematician. And this is, by the way, so Sergey's dad, Sergey and I were both working on different type of virtualization problems. His was substantially more profitable than mine. and his mom was on research grants with me. Yahoo passed on me. LinkedIn, Reid Hoffman knew about my research. Reid, who happens to be one of my best friends now, he had passed on me. So people just didn't see value. And so one of the things that happened literally is, and I was like, well, I have a PhD. I should be able to do this stuff. I'm highly qualified. And everyone's like, yeah, right. And so my mom happened to be at a cocktail party with Rajiv Dutta, who was the president of Skype at the time. And she just harassed him nonstop until he finally agreed to do a call with me. I'm not making this up. And so my mom got me my job. This is like at 28. Might have been even 30. Yeah. And so, and then I had a call with Rajiv, and Rajiv's like, oh, yeah, you seem like you're kind of smart. I'm sure there's something we can do. And that's how I ended up at eBay. And since then, one of the things that we found is we had to really figure out how to get people with PhDs into data science. And we started a program called the Insight Data Science Fellowship Program in the United States to help people cross over. And so there's a big gap. So this idea of that you need a PhD to do this type of work is flat out false. Focus on creativity. Focus on being clever. Those things carry you substantially further than any labeled degree.
Yeah, in fact, that was my next question, what you felt about it. But circling back, let's say if you were deciding about going to graduate school today, what would be your advice? What are the subjects which you think people should be reading? Because in India, a lot of us kind of tend to put people into either engineering or doing MBBS. But what are some of the streams you think people should pick up more?
So let's step back and talk about just undergraduate first, and make sure, like, just out of your major schooling.
Yeah.
When you go to undergrad, the first thing that I think you need to do is have an extremely solid base in the humanities, which seems contrary, is that you should deeply understand arts, how to write, how to speak, how to interact with people. And the reason for that is all the sciences become even more alive when you have that firm foundation in humanities. Yeah. And I was very grateful that I had one with so much theater and so much psychology in there. The second part is, your technical area cannot be determined by the building in which your classes are taken. Most of the time we go computer science, but computer science never talks to physics. And math is somewhere else, and chemistry is somewhere else, and biology is totally somewhere else. Those days are gone. Right? And in those days, increasingly, like, not only do we talk about the world being flat, industry is becoming flatter. That we have to radically rethink how this is going to happen. So if you're in computer science, you really need to know a bunch of physics. You really need to know a bunch of mathematics. But you should also have some really great understanding of biology and physics, or pick your favorite thing. So mine was, I knew not only a bunch of computer science, but I also knew a lot of oceanography and other things. For my PhD, I qualified in 2 areas inside mathematics and 1 outside my department in meteorology. And so I encourage everybody to think of yourselves as Daniel Pink talks about, be a T, be extraordinarily deep in one area, but be incredibly good across a lot of areas. If you're doing computer science, you really need to make sure you know much more about computer architectures and hardware specifically. It's the hardware part that's missed, because in a world of Internet of Things, there's a lot of pieces of complexity that you probably just don't appreciate. Similarly, if you're doing computer science now, you got to make sure you think about security more broadly. The other people who I think need to start thinking about security broadly are biologists, because we're entering a new phase of how these things work. Bioinformatics is going to become much more data science, is my prediction, because you can't just do statistics. You've got all these other messy data sets. And so we're going to see a radical revolution as we push increasingly into the genomic era.
So, So what happened to the plan of being a professor, and then how did the shift towards industry happen? So you joined Skype, and then how things moved from there?
Yeah. So what happened was when I was an academic, I just loved it. I mean, I really loved it. The Bush administration had really started, and there was a very strong contraction in research funding. So the writing on the wall was there about, like, this is not going to go well. We also had 9/11 and the first wave of people who had come in to fix and build those solutions to find threats against democratic process and interests. Those were getting built out, but a lot of people screwed up those technologies. So I was asked to come in and help fix a bunch of those. And I got a very strong crash course in what it means to work inside the government. And in particular, I showed up at the Department of Defense, and don't think I really saw another Indian. People would often look at me and you have your badge, and people would often ask, are you a citizen? Or do you have clearances? So it was a very different time. And one of the things that really happened to me was I got to spend really quality time with people who have committed their lives to serve for the protection of the nation. So I would get up early in the morning and go lift with the Marines. Which really meant just carrying around the weights. It wasn't really me lifting a whole lot. But the part there that it really transformed for me was the idea of what it means to really have mission and building long-term institutions. And when I was coming back to academia, so I did that for a year and a half. The max I could stay away from the universities too. And as I was coming back, the big thing there was just, where is industry going? Where is academia going? Research grants are getting cut down. And fundamentally, I just couldn't figure out how to be in the same city as my wife. We had a young child on the way, and so I had to find a resolution. And so at that point, Skype and PayPal were both part of eBay, and so they needed a lot more help to think about how these companies came together. And a lot of the first thing that I realized when I got to eBay Inc. and working with all these companies was the amount of data that they had was unbelievable. Also that nobody was using it. There was really not a lot of use. Like the best use was a little bit of how a user goes and does something, but nobody thought about, well, if you took this data here and this data here, it was so much more powerful. And one of the first places we realized the power of this was in fraud and abuse, and sort of thinking like, well, if you're abusing the eBay platform and you're abusing the PayPal platform, well, we use that data together. There's lots of new ways, and you did this at Capital One, so you know like any more data happens. And so one of the things that we started to build was these different models, and this was a time of random forests and everything, and we found that the models didn't matter. Like the lift from a model was very small. There wasn't a whole lot of advantage that happened to it. But the retraining and the cycle times, that's where it happened. So we built a neural network, 3 layers deep, back propagation, very fast retraining at 24-hour cycle. That sounds familiar. That's a deep learning system. And this was more than 10 years ago. But everyone was doing that. We just didn't call it deep learning. We called it not losing money, which is not a super sexy name for a technology. But that's really what it was. And once I was there, I got really enamored with all these other cool technologies. And that's kind of started this path to Silicon Valley.
And then what was the typical data size at that time? And then when was the first realization that the data is kind of growing much faster than what the systems could handle?
Well, this is exactly why I left eBay, because they couldn't do this. They didn't appreciate that data was growing at this incredible rate. And there was, like, we're talking on the upper side of petabytes, but it was really a terabyte world that you were existing at that point. But they just never had the conviction to invest in the technology to really take on these challenges. So as a result, we just said that there was no way that eBay was ever going to invest in the infrastructure. This is really early, super early time of Hadoop. So that's when, and Reid Hoffman had become, and I started helping advise LinkedIn. And I said, oh, well, LinkedIn totally gets it. LinkedIn had somewhat stalled on growth. So we said, well, what happens if you bet the company on a data play? And that's where we started to really do that, and that's where we invented all these new technologies like Voldemort and Kafka and all these things.
Interesting. In fact, I remember LinkedIn to be really smart about how data was used in the early days specifically. So this was probably the first time someone did that. So I visited the jobs page on LinkedIn, but didn't post a job there and left. And a few hours later, I get a mail in my inbox saying, right. So,
I wonder how that happened.
but I truly thought at that time that this feels so natural that I left there, but no one else in the industry was doing that at that time.
Would it be helpful to kind of go into some of the components that I think are really important for the data science community to take away from this?
Yeah.
So one of the things that really LinkedIn figured out and pioneered is that it's not about building just the recommendation system. It's about building the whole user experience. So most of the time as data people, we see an objective and we're trying to just optimize to some number. There's some ROC curve, there's something, and we're like, look, we think of the world as two-dimensional and precision and recall. We don't think about the experience. And so as a result, most data products feel jarring. They don't have the right touch in the field. They almost have a degree of arrogance. So what we really figured out was, how do you soften that up? So let me kind of walk you through two very different examples. So people we may know, super creative. Jonathan Goldman came up with it. People were scaling it, figuring it out. Facebook really figured out how to scale it. But our ability to really be good with this results was spectacular. So spectacular, we ran into a problem. And the problem was, you go meet somebody at a happy hour, or you meet somebody at some party, and then you come back to LinkedIn and you're like, whoa, how did you know I just met them? This is super creepy. And what's happening is it's effectively a triangle closing algorithm. It says, you know Kunal, I know Kunal, so we probably should know each other. Yeah. Simple as that. But that feeling of why is it jarring turned out that the people were always in your results, but you don't actually see them. You don't see results that don't make sense to you in that context. Because you're just like, whatever, you're just recommending people, I don't know who that is. And now suddenly it just stands out across everything else. So it freaks you out. So there's a couple choices. Do you dumb down the algorithm? Do you, try to do something else? Do you change, some of that? So we were very focused on how do we make sure that our algorithms have a graceful way to fail. So the real solution is not do anything to the algorithm. It is purely focus on just putting underneath it a design treatment that says, you know the following people. Same problem of a recommendation engine. Let me give you another case. I am going to recommend to you, Kunal, jobs. And I'm going to put it on your homepage of LinkedIn. Here's a recommendation of all the jobs you have. Well, now we have a problem, because how do I know these jobs are actually good for you? Well, we test and we validate, we use other people, we do all our usual classic stuff. But you see the job and you're like, well, I'm never going to move to this area. So that's a terrible job recommendation. Or you say, I am an executive. Why are you showing me jobs for assistant? Well, maybe it's assistant minister. Right? Yeah. The problem now of title and what is leveling, you don't have a sense. So how do you solve this? We can keep trying to get the algorithm better, but it's a game of just incremental inches. So what we would do is we take your results for Kunal, and I'm going to send them out to your best friend. And I'm going to put on that box on their homepage, I'm going to say, we found great jobs for Kunal. Why don't you send them on to him, the ones that make sense? And so now you're going to take, and it's all the same recommendation engine. And now you're sending, that person is sending recommendations to you. So in this case, who are you pissed at? Me or your friend? Yeah. So it's a super subtle shift. That subtle shift gives you extraordinary ability to create, take a product that's going to insult somebody and give you a way to make it soft. Yeah. And that's something that I really encourage people to think about, is how do you make the overall user flow work? Yeah.
And you said you were giving a second example.
Oh, that was the second one. It was the people. Sure. I can go on for many more of these. It's helpful.
Great. Yeah. So then you started on with LinkedIn, and then how did this opportunity of becoming the first chief data scientist came in, and what's the story behind that, and how did that happen?
Well, one of the things that had taken place is I had been helping just people in the federal government think about data, because they would come through Silicon Valley and we'd occasionally talk, and there was a friend of mine, Jen Palka, who had started a group called Code for America. There's a Code for India now, and sort of thinking like, how do we as technologists serve and help the government? And the CTO was stepping down, Todd Park, and there was an opening to say, who should be the new CTO? And so they called literally on the night that we had announced the acquisition for Relate IQ. So I went to my wife and I said, hey, I got the weirdest call today. Here's what happened. What should I do? And she said, you have to put your hat in the ring. You got to try. And I said, you understand that we'd lose the economics. And so we got to go do this. And she said, service is something that's incredibly important. You should do it. Which I couldn't believe she had that sort of insight and that ability. And so I applied, and there were 2 other candidates who turned out to be some of my closest friends. So we all knew each other, and they picked Megan Smith, who was phenomenal and was the right choice for the CTO. And at the same time, they realized that 2 previous CTOs had all been focused on data. They said, well, wait, what do we do about this data thing? And at that point, the president had also said, well, we need to make sure that data is central to the core of the United States, especially to the presidency, forever on out. And so as a result, all 3 of us were asked to come and serve. And we all took different roles. And so the role I took was this new one that we created, which is the chief data scientist. And in that role, the mission is to responsibly unleash the power of data to benefit all Americans. And the 2 really important things that everyone should take away, which I think is applicable to every data scientist right now, is the words responsibly. And that's just because we can with data doesn't mean we should. And in the case of the United States, it's all Americans. But there's no reason as a data scientist we can't abstract that for all Indians or all of the world. And we have to ask, how do we use these technologies to empower a greater platform of people? The thing that's surprising about the chief data scientist role is that the projects in which we worked on were some of the projects you would never, ever expect to find a data scientist working on. That would be healthcare reform in particular. How do we think about the next generation of healthcare? And what is genomic medicine? And that's because if you don't have data, you can't enter the genomic era. And so you have to think about not only file formats, transport protocols, all of these things, but also what's the training required for the next generation of biologists, physicians, everything. And that is going to require substantially more data. Yeah. We also were involved very heavily with all these questions around what we call officer-involved shootings. These are places where an officer is engaged with someone in the public, a police officer, and has had a bad outcome, typically a shooting. And so we were the people often in some of these very tense negotiations and trying to find solutions. Those are places that you wouldn't expect, but it was because every single time we worked on these things, the answers that were durable and having the greatest impact were all data or technology related.
Got it. And the part which you mentioned about using data responsibly, especially on a domain like bio or genes. So what were some of the challenges you faced specifically in these new domains, or healthcare at that time? Was it at its very early stages?
Well, I think the biggest challenge that we're all facing is coming up. So in ethics of data, we're just beginning to see how do you combine data, where is it, people have access to the data, but also the use of data. So there's an extraordinary amount that if you bring people's data together, you can find remarkable things that could find solutions to cancer or other diseases, type 2 diabetes. We know these are large data set problems. But you could also use that data to disenfranchise a population or to harm people or actively make sure that they don't get care. In the case of data that's being used to mining social media. There was a talk this today about India's tax authority using Instagram data. And I think there's a fair question in there is, do we want the government looking through these different data sets? Because maybe in this case we say, okay, that's good. Maybe in other cases we say, that's not good. How do we have that discussion? Well, the first basis of it is that every data scientist, computer scientist, economist, biologist, anybody who's using data, anybody out there, you must have ethics as a foundation of your education. So in the United States now, all these data science training programs and curricula all are having data science and ethics tied together to start coming up with common language so we can talk about it. The second is security, and that is very specific because if you're building a database or building something and you don't actually know about injection or overflows, you can't really, you're missing out. Yeah. And so we have to think about how do we protect data. And the way I think about it is we really have to ask ourselves, we say we're stewards of the data. I would encourage all of you to think about yourselves as guardians of the data. Stewardship of the data is not sufficient for the type of data sets that you're working on. And think of it as your child's data or your future child's data or your grandkids' data. Think of it as their data is in this data set. And what happens if it is exposed or abused or even corrupted? Somebody gets in there and messes it up. We have to think about it that way. Yeah.
So, when you went into White House, these were some of the challenges there. But this was happening for the first time. So much kind of attention at data. So, what was the initial period like, and then what were some of the challenges you came across at that time?
Well, the initial period that always happens when you're at the White House is very tough. I mean, it is, for the first 3 months, it is extraordinarily a painful learning curve. Like you really don't get a chance to sleep. You're getting used to every morning there are at least 2 crises, in the world that you have to address, and you need to deal with them very quickly because you can't let the urgent get in the way of the important. You're always got to be focused on the long-term outcome and never letting that get derailed. You're also trying to figure out where and how to prioritize things that can happen, and you have to address the political nature, but you also have to address the complexity of what is actually needed to get done and how do you get it done. And so one of the very first thing is I had created a countdown clock in terms of weeks left in the administration and sort of was very focused on time management of what's it going to take for each week. For those that are in software development, that's a very common model too. You've just got a release cycle. And so we were very focused on how often we're releasing. The other thing is it's just prioritization. And so you have to get ruthless in how you prioritize. And so you're aligning with presidential priorities that come directly from the president or the president's other team members as he's working on things. And then you're also focused on making sure that there's a few other things that you try to pick up as they kind of go on, because you never let a good crisis go to waste, and you try to move those forward.
And how did you go about putting the team in place? Because usually even at a organization level, people think about various roles. And you went ahead and put these 40 chief data officers in place. So what was that process, and how did that happen?
So there were 2 different processes. One of the things is we recruited over 200 technologists from outside industry to the government to do 2-year stints and come in and just help the government out. And those people came from all around the country. They just weren't like Google people only. But we were able to recruit from anywhere, and we rarely ever lost a candidate. And the answer was really simple, why we never lost people. It wasn't just coming to the White House. It was coming to deep inside these agencies. It was saying, your country needs you, and you have the direct ability to use your skills to impact the government, and people are going to take you seriously. And when that happened, that alignment happened, it was stunning. And the quality of people that we had like Alan Sternberg, who was the founder of Weather Underground and actually had coded up the original PageRank algorithm. You had people of that nature, or Kim Rockmiller, who's Jeff Bezos' like fix-it woman. I mean, she's like a superstar. So you had people of unbelievable, talent coming in. The other part, though, was of the chief data scientists, putting these 40 chief data scientists across the federal government, I didn't actually go and say, you need to have a chief data scientist. In fact, what we did is quite the opposite. We focused purely on showing the value of what these people could do. And when people were like, whoa, how do you get more people like that? That's what allowed it to take off. And one of the places where we did the biggest one was in the Department of Defense. And we literally had to move the team for a while right next to the Secretary of Defense's office, so they would have the right visibility and able to work. As soon as people saw what they could do, we had to really be careful about prioritization because everyone wanted their time.
Yeah. And then what was your biggest learning during this period? What was the biggest takeaway?
The biggest takeaway for me personally, and the way I like to say it is, people are always greater than data. If you focus on the people. We love to get caught up in the data, and we love to talk about edge conditions and edge cases. And we're like, oh, that's just an edge case. Those edge cases have names. Sheetal, Akshay, Jose, Rahul, John, Matt, Sally, they all have names. Put names against edge cases. Because what it does is it forces you to have courage to go a little bit more and address those situations. The big part as you start to build those out and you start to take on those challenges is you have to have those people at the table when you're building the technologies or the ideas of policy. When you do that, they come up with much better solutions when you're all sitting together. Because what you think is right, they think is right, is not. Together you come up with real things. And I don't mean some group that represents these people. I mean real people. In companies, that's a form that we call user testing. But you got to do that even earlier. Bring in people to work and build with you. And it changes your whole approach to how you tackle these things.
And one of the questions which we got as part of the community questions, and I'm taking that up deliberately, is now with your experience in, with the White House and the way things stand in India today, so what are some of the things which you think the government should take today to make sure that we prepare for the future?
Yeah, and so one that's out there that we should talk about is Aadhaar, because that's in the news. And the first part, as I will say, is like, I am not up to speed on all of the nuances, so it's not appropriate for me to tell anybody what is right or wrong with Aadhaar. That's a discussion that needs to happen here inside India. But here's what I would advise is the first part of this is you look at these technologies. These technologies are incredibly sophisticated. And they actually work. They didn't fail on the outside. Like, they got built. They got, healthcare.gov was built the first time. It didn't work. The servers didn't even work. In this case, stuff worked. It's a question of implementation then. Part of that rationale is you had policy people working directly with technologists. And so hand in hand, they were able to figure out how to make it get executed the right way. What I think is really important now is a question of how is this technology utilized and when is it appropriate? So you've built this, India's built this phenomenal hammer. Does everything suddenly look like a nail? And should it be used in this case? Should it be used in this case? Should it be in this case? That's a conversation that is going to be done best when you have policymakers with the technologists at the table and real people, not these lobby groups or other people. And so what I'm concerned with, and based on the very limited conversations that I've seen happening, is it's really policymakers that are having the conversation. I don't even see technologists at that table helping say, like, this is good or bad. And that's where this question of privacy really needs to rise. And this is the best thing to do is have this in the open. This needs to be a public debate that is extensive because it's going to change over time, people's comfort level, all of these things. But if you don't have it, and what I'm encouraged by is that the conversation is happening now, and there's even more that needs to happen. Second thing that I think that's been really amazing is when I was in Mumbai, I was able to meet with 40 fellows who have come in to work with the government of Maharashtra, and they are top-tier technologists who are saying, I want to be committed figuring out how to help people in rural parts of the country, or that, in this case, rural parts of Maharashtra. How do we think about education? How do we think about food? Technologists doing a period of time of service in these organizations lifts up the entire government. And the other one, which is there, which I advise the government, is the same way we talk about edge cases here, we should really talk about the edge cases of society. And two pieces of advice that I learned acutely is every morning in the White House, there's a stand-up meeting in a room called the Roosevelt Room, which is right outside the Oval Office. And that stand-up meeting is run by the Chief of Staff, and you start with anything that's important that anybody needs to know and a quick review of where we are on the president's agenda. And you look around that room, and it looks like all of America. Mexican, ancestry, Black, Indian American, American Indian, religions, Christian, Muslim, Hindu, Buddhist, atheist. Doesn't matter. Gender, sexuality, straight, gay, transgender, doesn't matter. It was all around there. You saw it all around. This wasn't a gigantic. This is like just, about 40, 50 people. And so it changed the nature of where we saw problems, because you'd say, hey, what about this? And people would be like, oh, I think about it this way, a solution that you could never see. So in the case of India, what I would tell everyone is that the United States has an extraordinary superpower, which we call immigration. Immigrants get the job done, as they say in Hamilton. And, U.S. has benefited from India's expertise disproportionately as a result. And India has extraordinary diversity too, because there are 1 billion people here from many different parts of different places and cultures in the country, but also religions as well as gender and all the different points. And if India starts to embrace more of that, rather than finding ways to secularly define it, I think that's going to be, that'll be a force multiplying effect that I saw personally take place between the Bush administration to the White House. When I was in the White House, by the way, in the Department of Defense originally, over 10 years, there was no other Indians. So going to the White House, there was a lot of Indians in not only the White House, but in all sorts of other departments. Some of you may have seen this thing that happened where even there was 2 Indians who were presenting, they were Indian citizens, and they were presenting to the Congress, and the congressman suddenly started saying, well, I love India, I love Indian food. They didn't realize, oh wait, there's so many Indians actually who are serving in the government now. And that, embracing that, I think is critical.
Got it. Great. So moving on to kind of the next phase, and while I read on Quora that you are catching up on your sleep nowadays, what next, and then what are you focusing your energy on now?
So my current energy is going into healthcare, and we've had this very extensive debate with anybody that's been paying attention to the politics in the United States, where one party has been particularly focused on ripping away healthcare for people. And I've been very concerned about what that looks like as we enter the genomic era. There's similarly questions I've been really fascinated with and really focused on of basic human rights and what it means for people to have wellness. In particular, around that wellness are women's health issues and other things. And one of the ones that was one of my great regrets in the White House was not pushing more on this issue, which India is having discussion on right now, is a question of sanitary napkins and tampons. And we just think of that as a silly issue oftentimes of oh, what is this? But really asking whether we tax it, do we make it openly available, is that whenever we take basic things that are there in our society, and that includes elements of food, water, safety, security, and humanity, and you lift those up, you see just everyone is not only happier, but people have a better quality of life. And so focusing on those things. And I think India has a supreme opportunity to take and leapfrog over many countries that haven't figured this out. And I just was hearing this one today about the sanitary napkins. I just think there's an incredible opportunity here for India to take the lead and do what's right for the people. And I think that's happening more across the world.
Coming back to the domain itself, data science, and there is a lot of movement and a lot of dynamism which has come in. We have seen deep learning grow. We have seen many new tools and techniques coming. How do you see things going forward, and then what are the areas you see as going to become the major focus areas?
My number one advice to everybody is do not focus on just tools. If you're going to become a deep learning expert, that's a very dangerous place to be. Because if you were a computer vision person who only focused on edge detection, you just got crushed by the by the deep learning world. But the same was true of like random forest to this. And if you go back 15 years ago, 20 years ago, you were a neural network person. You were out for about 15 years, and now suddenly the world is hot again. I prefer to think of these things as these are a set of tools. These tools enable different problems. Get versatile with them, but solve hard problems. Focus on solving hard problems. There's a lot of great new things coming around to binding technology with hardware. Very interesting. Still early. But there's also a tremendous amount that's happening in real-time analytics, but also offline, larger scale processing. Specifically in the healthcare space, as we get into genetic and genomic medicine, the bigger thing that's there is we're going to be moving around as much data as you see being moved around on video between YouTube and Netflix, just for your DNA, very quickly, and definitely by 2025. So we got to get ready for that. The self-driving cars or autonomous vehicles, planes, ships, all these things are going to be throwing off unbelievable amounts of data. Ford estimates that their new cars are going to produce about 4 terabytes a day of data. And that, I think, is low as sensor curve continues. Smart cities are going to throw off more data. So the opportunity curve for being in data analytics is phenomenal if you're projecting out how this goes. But you also have to ask what skills are going to be required to capitalize on that data. Data is just a raw form, and you need to be in that process of figuring out what's there. I would love problems like ETL to get eliminated because it's just so painful. But also I think India has to get ready because much of India's IT industry has been a service-related one, where that service-related wave is going to start ending. And it's been riding it for more than 10 years. And a lot of that is, and you just saw this, the growth numbers recently are not what I think anybody would like. I think 2 to 2.5% growth. And a lot of those things that what they've been doing of testing, like unit testing. What engineer likes to write a unit test? Like that's terrible, right? You don't want to do that stuff. There's a lot of dashboarding. When people say data science is going to get automated, great! Automated. Just automate the crappy stuff that I don't want to spend any time doing. Like, stop making me re-add these numbers up and trying to figure out why these two numbers don't match. Take away that stupid stuff so I can work on some really more interesting problems. Like, I want to I always tell people, if you're doing a bunch of data science, should you be doing that data science? Or how can you fire yourself out of that job? And that's generically true for anything you're working on in any company. And one of the things I advise any founder to be working on is the first thing I tell them is like, what are the things on your list? Show me your list of things you do. Because there's what you tell me you do, and there's what you actually do. And the way you do this in a company, if you're investors, you say, don't tell me what you do, show me your budget, and I'll tell you what you do. And so you look at somebody's calendar, and I'm like, ooh, that's how you prioritize. You need to fire yourself out of this, this, this. And now let's ask ourselves, what does it mean to fire ourselves out of that? What kind of person or organizational structure is needed so that you're free up that time? And that is a powerful model throughout anything you're doing in life.
Correct. So the data science would become more and more assistive in nature and kind of take away some of the unnecessary work or not the...
I would hope, but I think it's going to open up a turf of different kind of messiness. A very different kind, because we'll be bringing much more data sets together, and those data sets, we still don't know how to address provenance of the data to be combined across very different data sets. So, the lineage of the data, for those that aren't familiar with provenance, is like, how did this change over the arc of the data sets? We don't have a GitHub-esque world for data science. There's some early type of things going on, Data.world and others. and datascience.com is trying to do some stuff. But these are early, and there's a lot more that needs to happen. So I expect and the same thing happens with AI, is this is actually not going to reduce jobs. This is going to substantially likely increase jobs of a different portion, but they may be jobs of a very different nature.
Yeah. And that kind of brings to a recent debate which we saw between Mark Zuckerberg and Elon Musk, and then both of them taking extreme sides in terms of how they see world. What's your view on it, and how do you see AI coming in and then changing the world?
Yeah, so you usually don't want to get in a fight between Zuckerberg and Elon, or have both of them gang up on you. But here's where I'll say that when the arc of what I think are most relevant problems for society, I'm not disagreeing with Elon that's saying that we should be thinking about what are we doing with AI? Like, we should really be thinking about it. But I'll tell you where I'm most concerned we should be thinking about AI is people are building algorithms, and we're not asking ourselves, do we have good data training sets? In the US, one of the ways to think about it is if you're building a self-driving car, but you're only training it in certain neighborhoods, is that training, is the car going to be able to see someone with a sari? Is it going to be able to see somebody with a hijab? Is it going to see somebody in a wheelchair? It may not. It may not see people of different racial ethnicities. So how do we make sure that's in the data set and we're thinking about it that way? How do we make sure there's not implicit bias in these algorithms? We have seen AI that is racist. Yeah. It's very concrete. I'll tell you one that is super painful. Somebody built this system for immigration, and you go into immigration, and it's taking your picture and trying to make sure, and so it's got a little lightweight layer, and machine learning, it says, don't smile too much, make sure you don't tilt your chin too much, open your eyes, and somebody didn't put enough Asian people in the data set. So the thing's saying, like, open your eyes, and they're like, my eyes are open. And you're like, well, it's like, open your eyes. You're like, I'm open. And you're like, well, there's no help button to be like, somebody override the system. You're sort of trapped now. Yeah. You're like sort of trapped in this sort of like weird sci-fi sort of conundrum. You fell through a crack. Yeah. And so we laugh about it in this case because it just shows the stupidity. But that crack, as we move to an increasing digital society, we don't know how to think about, because oftentimes somebody shows up on a screen and we say, oh, yeah, we trust the screen. We never thought about maybe there's latency in the databases, and that data that's actually presented on the screen isn't up to date. Maybe there's other stuff that says that there's an implicit bias in this thing. We're seeing personality tests being used to judge people for a job. How do we know it's actually taking into account an unbiased way? How do we audit these things? Mm-hmm. So I'm much more worried about that. From where machine learning stands. Do I think about AI in a 10-year and 20-year arc? I absolutely think it's important. But if I had to bet where I place my bet for human society right now, it would be on where we're going to end ourselves: drug resistance, tuberculosis, pandemic, Ebola, nuclear war. Really focus on the question of how do we make sure that we have sustainability across clean energy? These disruptions that can happen across society are so much more than worrying about a sentient being. I'm more focused on those kind of questions, and that's the appropriate dial I would look at for what we need to do. Also, I think it's just like a question of, if we were to regulate AI, what does that mean? I just don't. I struggle with how do you actually take policy and implement it? Because you have to also be very careful. If you write a law doesn't get changed for something like 30 years oftentimes. So one of the things that we did is we implemented the policy structure for autonomous vehicles, drones, and everything else, because I have no idea what drones will look like in 10 years. I have no idea what drones will look like in 2 years. I'm excited by the potential that drones can be used for amazingly good things. I'm also deeply concerned that I can use a drone to deploy, some kind of threat.
Yeah. Okay. So, in terms of just laying out the way you see things going, when do you think, or so when do you think machines would start helping people in their day-to-day lives making decisions? So, for example, a doctor getting commentary from a machine.
Well, it's happening right now, but it's happening in ways that are very subtle. How many people used mapping software to get here? Right. People who aren't raising their hand are actually lying, so don't worry. Because we all are doing that right now, right? Yeah. We all also open up a weather app to see is like, actually, it's cloudy. Is the monsoon finally going to be here? We are interacting, and we also don't. If I just said, do you know where your phone is right now? You have that moment, you're like, actually, wait, I actually need to check where I missed that flight. And if you've lost your phone for a second, you have a feeling of almost deep pain. You're like, oh my gosh, did I lose my phone? It's actually, many times you're like, I fear losing my phone more than my wallet. We've moved to that portion of society. And so what I say is the phone you have to think of as like a superpower. Like think Superman or Supergirl, where you take kryptonite and it actually hurts you. If you don't have your superpower, in this case, that the phone, you don't actually know how to live. And I think we need to be very careful also of, as we're inventing and building these new superpowers, asking for those who don't have access to it because of where they live, the economic structure, what does it mean for a world of people who have superpowers and those that do not, or those that we actively do not allow to have superpowers? And that is a very dangerous way to imbalance society.
Okay. Interesting. A trip to India can't be, complete without talking about Bollywood or cricket. Yeah. And do you follow Bollywood or cricket?
So I'll tell you the way I follow Bollywood is because I follow it because of my wife or my kids. But there's an interesting thing. So we don't have a TV anywhere where we actively sort of stay in our house because we strongly believe that we have, and this may seem weird as a technologist, is like we fundamentally believe in a lack of screen time. Is that there are times for using screens and there's a time for actively not using the screen. So during the weekdays, there is no screen time allowed. And so we don't want TV or anything in the background. My kids and my wife obviously do love Bollywood. My wife comes from a Bollywood family, and a whole bunch of friends are in Bollywood, so I get exposed to it. But I'm not, I find because of that I end up doing a bunch of reading than anything else.
Mm-hmm. Yeah, my next question
But I do read a fair amount of Indian literature when I can.
Okay. Maybe then that's a better question to ask. So I was going to say, when do you expect, machines coming out with these literature which are written? And today there are, but they don't make sense. So when
for when they can actually construct literature, I don't see that happening.
Mm-hmm.
What I do see is happening is, and I'll tell you very specifically why. We try to build these news products. Of like trying to say how do we recommend news for you. And it was an incredibly painful process of saying, like, this is what a newspaper should look like. Because you just say, this is an important article, this is an important article. But it didn't have a flow. And so what turned out, what we realized is, no, we're doing this wrong. We shouldn't be actually trying to give you as a user the exact information from the computer. We should be building superpowers to aid the editor to allow customization for you. So we might come up with a page of the homepage that would have the best news, but then we'd have the power for the editor to move things around and make it flow. I think a more apt analogy of this is, when do you hand over a restaurant menu to, or a kind of a rich tasting menu to for a chef, to a computerized process? You don't, because most of the time if you're serving, well, I was going to say, if you're serving jalebis at the front of the meal, that feels weird, but that actually kind of would be great. But there's kind of a process flow where there's certain things you just don't mix together. Chefs can explore and try and come up with novel things, but this augmentation is much more important than actual creation. And that's what you're seeing. The best things that are out there is, if you look at the curves of performance in chess or poker, and now I think we're going to see the equivalent in Go, is humans by itself will get beat by computer. But human plus computer always beats computer. There's a slight subtle shift in there is if it's a super expert human plus a computer, that does worse than an amateur plus a computer. And that's because we try, as a human, we try to override. It's kind of like you're like, oh, Google Maps is stupid, turn here, and you're like, damn.
Yeah.
You know, that was actually right. But there's other times where it is wrong and the human needs to override.
Yeah. Got it. Great, thanks. So there were a few community questions which we collated, and I think some of them might be on the slide at the back as well. So the first question was from Shivani. So she's asking that, what would be your advice to students or data science folks who are in their early 20s? How should they think about their career?
Yeah, so early 20s, such a phenomenal time to just start playing with data. Just play with data sets, find people. But the most important thing that you can do in your 20s as a data scientist is grow your network. Yeah. Find the people that you can trade notes with. When I was in my 20s, one of the greatest things that happened, especially in graduate school for me, is I got to work with these incredible people from very different disciplines. And they were started to get interested in these ideas of genetic algorithms. They also got interested in this idea of autonomous, sort of agent-based design, and how do you actually create algorithms to do these things. And so I learned from them. I didn't have any, I was not, none of it was relevant for my research. Fast forward 20 years, 15 years, and I was like, oh, thank goodness they taught me about this stuff. Because how do you think about adversarial network design for deep learning and neural nets and all these things? These all things kind of fit together. Yeah. So just being exposed to that happened through people. The same way was as we were building data science and different technologies, finding people who are trying different things and seeing what have you taken away from them. I'm a big believer in that there's a difference between experience and wisdom. And most of us go through and we try to have a lot of experience, but we never step back and try to distill what we have gone through into wisdom. Yeah. Some of that happens when we just sort of sit back and think. Another portion of that is when we talk about like, oh yeah, that was a stupid idea, or oh yeah, I wish I had done this instead, or wow, that really worked well, we should do that again. And if you talk amongst it as groups, you're going to see a bigger benefit. On the very technical nature of these things, some of the technologies I think that are coming up is that you got to just be proficient on is definitely Python. We're seeing a really interesting movement of Julia. That's still early. But some of these other packages, R is there. It's really powerful, but we're not seeing it being able to be deployed in production in the same way. So I think there's a lot of interest there. But having familiarity with a lot of these languages. Also having the basics to really understand how do you deploy in cloud environments across the spectrum, but specifically knowing how to use Hadoop and these other type of things. But same familiarity with Spark. You need to move the data around, so actually understanding elements of Kafka or other type of data buses. If you're an enterprise, there's proprietary ones as well. I'm, of course, biased to Kafka. But, and then key value stores and Dynamo and these other things. But we're also seeing a lot of other things happen around search indices and other type of technologies that are equally as important that you should get familiarity with and trying and playing with things. So not just static data, but what I would call data that is evolving very rapidly. One of those best places to think and play with that is in the security domain. Mm-hmm. Starting to get exposed around those things.
Got it. So a mix of basically the same T-shaped curve which you mentioned. So
and your T will evolve, but you need to learn from a lot of different people as data science is going on. Because it's evolving so fast, get the people that are going to carry you forward. So I'm very fortunate that if I have a question on deep learning or AI, I'm going to call Ed Felton or Fei-Fei Lin or Hillary Mason or one of these type of people. If I want to understand deep technical structures on logs, I'll call Neha Narkade or Jay Krebs or John Rao, Chris Rickamini, and those type of people. And so I can just, and then if I want just very pure data science of how to be clever with algorithmic design and user things, one of the best people in the world is Monica Ragati, and I'll just call for her. And so I always ask, so what are you learning? What are you finding? What's cool for you? And then the most single powerful thing I can tell you in your 20s that you can ask is there anything that I can be of help on? Can I be of assistance? Learn how to help each other and collaborate. That is something that is exceptionally powerful.
Moving on to the next question. This one is from Gurudatta Shinde. How data science can be used in Indian government for benefit of people? Kindly guide us from your experience with US government.
Yeah, the best example is for the Indian government to find pathways for people like all of you to come in and spend a bit of time helping the government, being an active citizen, and building process and technology jointly together. That would be number one. Number two is making sure that policy people and technologists are at the table from the start. So making sure the table is a bit bigger. Yeah. And I saw this very personally from President Obama, who would very regularly say, like, why aren't these people here? And they'd be like, well, they're not normally part of this process. And he'd be like, they are now, because we need to, the goal isn't to just figure out, the goal is to get the job done correctly. Yeah. And if technology is good, which we know is going to have a disproportionate impact, we should take that.
Okay. The next question is from Pushpalata, and she is asking, after spending some time in India recently, what is your opinion about Indian data science crowd? How is it different from that in US, and what is your advice to the community?
Well, the best part is there is a community. Before there wasn't one. So it's amazing, and you know, credit to people like you and who are in the rest of the team and groups that are coming together to make this happen. These are community. When these are community efforts, they're substantially more durable and they last longer. I think there's a lot of great stuff that's happening. The part there that I would love to see is this jump, as we were talking about at the very beginning, was that data scientists here start moving into actually building new technologies, owning things, and not just sitting on technology that has been invented in the US or Europe.
Yeah. The next question is from Karthikeyan, and he's asking, what areas of analytics would you suggest Indian analytics companies and startups to focus on, and both from near future and long-term perspective?
The one that I think is most exciting here that India has ability to catapult on is smart cities. Because there's a big question and conversation about how to instrument. Data scientists are the ones that are going to figure that out. If data scientists aren't involved in a city construction of smart cities, I am happy to wager a substantial amount of money that's going to fail. Yeah. Because I just know, like, there's just no way that anybody can think about what a data scientist needs to make that data be usable, but also to make the true notion of a smart city work. Yeah. You can't have smart water flows and other things if you don't have a data scientist thinking about that. And so that's number one. The second one is, I think there's an incredible opportunity with healthcare. India has a very large set of challenges that are coming up. Across as a population both ages as well as grows predominantly in the younger generation. That is going to be across two dimensions. One is in the area of type 2 diabetes, but also cancer. And as cancer comes across, the ability to bring data sets in unique ways to find solutions and long-term wellness is really unique. And then similarly, the one that we don't talk about in India is mental health. And being able to address questions of suicide and other types of illness, and starting to remove that from being a stigma to accepting what's happening there and finding solutions. That's why I was really happy to rejoin the board of Crisis Text Line, because we realized, you know, in this day and age, who wants to call in to a suicide center or needing help, you text in. And the growth rates of those services has been astronomical. And that's not a good thing. That just shows actually how much pain is out there. And we need to use technology to augment people. We're not trying to build chatbots to help just talk to you. We're trying to get people to talk to help real people to build empathy. But you can't serve the demand without technology aiding and assisting in that.
The next question is from Chitra, and we touched on this briefly, but what she's asking is, do you see AI replacing the structured thinking process which humans do today? And can it really understand customer needs better than what humans do in the longer run?
I don't think it understands customer needs better, but it surfaces interesting things. This is a general one that, let's take AI out of it, but if you talk about data science, there's this constant question of, do you trust the data or not? And the first thing I tell people is, look, we're human. One of the most powerful things about being human is you develop instinct over time. You have a gut. And that gut tells you, no, this versus this. And so the way to actually make that come alive is sometimes by listening to that and then figuring out how to make that instinct testable. How do you make it testable with data? And so you're able to iterate to see if it's correct. Maybe it's wrong. Maybe it needs to be adjusted. There's other times that you look at the data and you're like, that's weird. That's surprising. And you use that result to then develop your instinct.
Yeah.
And so building that hypothesis is really important. But never ignore reality. Just type into Google or Bing, pick your favorite search engine, GPS cliff, and look at literally how many people around the world drive off cliffs because their GPS told them to. Which is shocking because you're in a car, you have windshield and glass. So that means you're actively ignoring reality to choose to drive off a cliff.
Yeah. And that kind of opens up the debate again on the self-driving cars as well. That they are there to assist right now, not to take off. So we'll just take a few open questions from people out here. So any of you who have a question, volunteer, maybe if you can reach out.
So far, I only see guys raising their hands. There's a lot of women here who should be asking the questions too.
Maybe let's take the first question from a woman. Anyone? Yeah. Can we have a volunteer?
Right up there in the flat. Yeah, go ahead, stand up. Maybe shout your question. So let me just summarize real quick because in the security domain right now, especially given the rise of malware, we've seen it particularly in Europe getting paralyzed by ransomware. The signatures and how the way people currently think about it. What are alternative techniques, or where is this going to go long term? Is that a fair characterization? So one of the biggest, most powerful areas that is ripe for just coming up with new innovation is in the security domain. Some of that is in the malware area and thinking about new ways that data science can be applied to it. I think there's been some of the classic signature, but there's a lot that's about to just change in the way people characterize it. In the same way that people used to say, oh, we only characterize music in search of music types in a certain way of saying this song is similar to this song. Early on efforts were called the music genome. I think we're going to see a much stronger evolution of not just signing and signatures around malware, but a much deeper level of classification of how those things work. The other part that I think we also have to expect is that most of the time work has been manual or craft related. It's been experts who are in the field. And much that we can't handle the derivative types that are coming. So you have to figure out new ways to get leverage. And that leverage is going to come about fundamentally through data technologies and machine learning and other things. We also know that if you're getting attacked right now, and we saw this with the most recent ransomware attacks, what they were doing is they were sending out messages to try to get you to click on the link, but those messages were actually being piped back into a machine learning layer, so they were evolving. So people are already using machine learning and AI to figure out how to attack you more efficiently. Port scanning will be an AI-driven activity. So security will move into an AI, machine learning, data science, whatever you want to call it, realm. And so equally as much as that happens, we have to think about the defense side as that approach as well. And so I think any attempt to try new ideas is good at this stage because it's at such a rudimentary level. Sure. Great question. So the question is, as we think about what we saw during the Obama administration and how we got tremendous leverage out of the data sets, what is that ability what does India need to do to get kind of the same leverage out of it? So fundamentally, the answer comes down to if you don't have the right type of technical people at the table, you're not going to come up with the answer. Many, many times over, the number one answers that we would come up with, people would say, oh, I didn't even know that was possible. That's really surprising. For example, one of the ones that we did was after some of the race relations issues and the officer-involved shootings, we got a whole bunch of police officers and civic activists and technologists, and we locked them in the White House in a big room with presidential cupcakes. We said, you can't come out until we figure out something. And interestingly, what happened is all these chiefs, everyone agreed that, wow, if we opened up more data and asked people to look at it, we'd probably find things that we didn't expect. Because I actually have no idea how my city is doing compared to your city. And probably the same way, you have no idea if Mumbai police and Delhi police operate the same way, or if some portion of Delhi and another portion of Delhi operate the same way. Do they stop men and women equally? Do they stop Muslim and Hindu equally? Or to the right relative ratio of the politics, not the politics, the population. So those questions nobody even knows, and we just opened those up and found you really started to get interesting things. So using that to get more insights is great. And some of these data sets that we got opened up were astonishing what people would come up with, and some cases, they were using very sophisticated technologies. In other cases, they were just using very elementary heuristics. But opening things up was the number one lesson in getting it out there. And getting comfortable with saying, look, this is a V1 data set or an alpha. We don't know, but we want you to, it's so important, we want you to start playing with it, but we're going to commit to improving it and making it better over time. That's what gave us the great leverage. But that only can be done when you got really strong people there. Well, how long is it going to take for India to get there? Here's the good news. It's like there's a community here of data scientists. When you start holding politicians and policymakers accountable and saying, look, this is what we can do, that's when the change actually happens. And the same was true in the Obama administration, is you have these technologies and other people saying, why don't you do this? And then once they said, actually, that seems like a reasonable idea, let's do that. Then more stuff started to happen as a result. And so success begets success.
Next question.
Going by the figure of per capita income, India is not a very rich country, but looking at the GDP figure, we have a lot of money. And Indian government has to spend a lot of money on many purposes like defense, healthcare, as well as education. And considering that we have a lot of people in our country and considering the proportion, there is not a lot of money for every person. So how data science can help the government decide the budgets, how to spend money on what thing, like considering the healthcare thing, how much money they should spend on what thing so that they can increase the benefit and give the benefit to the people in best possible way, as well as one other aspect of this thing is that how government can control corruption using data science. I mean, if you consider railway sector, there is a lot of corruption, like from TT to like go book a ticket or anything. Like there's a lot of corruption. How Indian government can incorporate these feedback systems somehow. They're getting feedback from the public or anyhow they're getting feedback and trying to analyze how to reduce corruption, what is the level of corruption and all.
Yeah, good, terrific question. Let me give you a super disappointing answer. I don't know. But I know who does, and it's all of you. That's the good news, right? These are homegrown problems. Right? They're very specialized to India. And the only people who are going to have context enough to do them is all of you. So how would I do it? Well, the first data point that I would tell you is that an interesting aspect of the first portion of budgets, that's been typically done by economists. As people are studying in the United States for economic degrees, larger portions are asking for the data science kind of classes because they want to know how to play with different data sets, bring things in ways together so they can ask richer, deeper questions that could not be asked before. So you can get to smarter answers as a result. That's allocation of dollars, that's studying what problems you want to have. You can just get better with that. Another one is you just open up that to the public and say, well, here's a tool that you can use so you get to decide and see what the outcome and the choices are. Those things are really surprising because you're like, oh, we never thought of that. If you're listening to the population, most of the time the population already has the answer. You just have to listen and hear it. On the side of corruption, this one is super ready for India to attack right now. Because as data starts becoming more ubiquitous throughout these layers, you can't hide around that data. And if you open it and make it transparent in those systems, it naturally sticks out. And so that's the place where I think is superb to attack. And even in the United States, in our healthcare sector, we're finding there's large amounts of fraud, but you can attack that fraud through data science techniques, and it stands out super obvious. It's really obvious. And it's interesting that as countries, we're really willing to invest in everything you talk about on the national security side, but we're not willing to invest on parity to do those same things on the domestic policy side. We're willing to look at signals to find where a terrorist is. We're not willing to look at where the corruption is. But the problem is the same thing from a data science perspective in many cases, or at least having allegory. Oh, you're picking. That makes me grumpy if I pick.
I think let's pick that side, maybe the lady over there. Yeah.
Agriculture is like the most important problem in India, and like farmers we have, but nobody wants to take look into that field. Like in GDP also, in India's GDP, 56 and 60% comes out of agriculture. So how data science can be helpful for farmers, and how we can use this technique to evolve them, like how we can use these techniques to evolve the agriculture sector.
Thank you for raising the question. So in agriculture, one of the great challenges right now is how much of our food just goes to waste. It's 30, 40, 50% at times where the food just gets wasted from the time it's harvested to actually it gets to somebody who can use it. So I think data science on increasing logistics is a great opportunity just to making sure that we don't have waste across the problems. We also know that the next generation of genetically modified crops and other things are likely to be data science problems. And there's a fear of what we talk about genetically modified organisms, in this case GMOs, around this. But remember, the derivative rice that was really created was what has, and the yield that we get out of our rice is a genetically modified crop. And that has provided the ability to sustain the population. Now, I think the same question I have talked about earlier about the ethics and everything need to be integrated of how far we carry that. The other portion is as you get into fields, making sure that you're not using pesticides in ridiculous amounts. You're starting to see people who are thinking about the use of drones to just micro spray in certain areas where you have detectors where there are pests or other problems, but not always having to spray everything in this broad-based way of using ridiculous pesticides. Same way with smarter irrigation systems. We're seeing that as we also go to hydroponics, that activities, those things. I think that's really interesting and exciting. So it's open, it's ready to go. I think one of the things which would be wise from a policy perspective is we subsidize so much money, put so much money into subsidizing the food supply chain. Also subsidizing technology to actually go help that problem would be wise as well. So we're not just paying for people to produce more food and trying to do that, but incentivizing really technologists to come and say, yes, we're going to go find a solution for that as well.
Actually, maybe the person.
But it was. So just a clarifying question here. Do you mean what language to deal with the graphics question? Oh, okay. The question is, so what languages do you use to go from 2-dimension to 3-dimension? So there's, one of the very exciting ones right now that people are starting to play with is Apple's AR kit. So some very interesting work there. This is still very early in the augmented reality space. I think the virtual reality space, we got a long way to go before we're still there. But augmented reality is moving much faster than I would have expected. And I think we're going to see really, really cool things happen as a result of that. The AR kit, does anybody know if, I have not played it anywhere.
Apple hardware.
It's just, it's bound to Apple.
Yeah.
So that's, Well, the AR kit you can go download. It's an SDK. You can go grab it and play with it and start implementing. It's like iOS. You can start playing with it that way. But the other problem is if you want to work with 2 to 3 dimension, the thing that I would actually encourage you is look at things like ray tracing and a bunch of these other related domains of how people actually look at these things. Because one of the cool things that you're starting to see, especially with some of the machine learning, is that you can actually separate depth and start figuring out how to do this. So one of the powerful examples as a result is you can take a traditional, like the Apple has in the 7 Plus phone, it has two cameras, so it can give you parallax, and therefore it can give you a portrait mode, but which sort of separates, blurs out the background, but makes it really nice. You can do that with a single image now, just by using machine learning, because the machine learning can start figuring out depth. Now, can you go to full 3D reconstruction? Probably not, but if you have motion and enough motion around it, you could. So using stereographic cameras. And we're seeing some of this happening around companies like Jaunt and other things. So it's still very early days for what we're talking about, but there's very interesting just generalized computer vision. And the problems you're talking about still very much are in the realm of basic research, which you'd find at a university versus in companies. Is the current assessment I have. But if other people know about that, you should, please, you should raise those as points, because it's an area that I have not spent enough time in.
Maybe the person there.
Yeah, so particularly the EU has changed a number of privacy. I think that's what you're talking about. Right. Yes. Right. So here's where I think this is going. Is we are seeing a few companies and individuals who are bringing data sets together in ways that they shouldn't, and they're doing things with data that they shouldn't. And as a result, the regulators come in and say, hey, you really shouldn't be doing that. You know, for example, in the case of Uber, as it's been reported, they were using this technology called Grayball that they had built and is using it to evade regulators. Or you're seeing, you know, most recently, and was the Roomba, which is this robotic kind of vacuum, and they were saying they were going to sell the data. Now they've said they never said that. I don't know what is true in that case. But the fact that people kind of look at that and go, wait, you want to do what? You want to, I never agreed to that, or I didn't think I agreed to that. You know, when that happens, that's when regulation gets ahead of itself. And the backlash because of that regulation affects a much wider swath of the industry. And so what I think we have to start doing is, as a community, saying like, no, you should not be doing this. Or that is a better use of data over here. Because otherwise regulation comes in and it's going to be very brutal. The place also we talk about most of the time is we focus on consumer internet companies. There's a large set of vendors which are called data brokers who go collect data in very sort of, you know, almost gray areas, particularly in the United States. They collect this data and they use it to aggregate it and they sell it, or they use it on systems that you have no visibility into or no recourse. That includes these people in the credit loan industry of how people assess your credit. And you don't have ability to say like, wait, that's wrong, or that's actually, you've mixed up two different people. And so we need a better way of having transparency in that. Otherwise, what happens then is regulators just say, nope, you can't do that. And that has other wide-ranging impact. That's right. The recommendations is you may not be able to say it. You use these things. As just a very concrete example, here's the kind of interview question I would encourage all of your companies to implement. A variation of this is to say, we're supposed to build a recommendation engine, and we know that we're not supposed to use race as a proxy or gender as a proxy or pick something, or just let's take the word proxy out. We're not supposed to use gender or any of these things. Yet we discover we found a proxy variable. Like, wow, okay, this is good. What do you do? You know, there's no right answer here. There's a conversation that we should have about how do you actually discuss this. You know, do we say that's okay? How do we check it? Do we talk to legal? That's the conversation I would like people to have, so that we start asking ourselves the same level of depth about should we do something as we do about can you build a recommendation engine? Because that's where stuff goes wrong. It goes wrong really fast. And more people are going to get caught by it. It's very easy to catch because people build the online tool and somebody hits it from a whole bunch of different variables and they're like, look, this is crap. You know, the most recent one, or not most recent, but one we saw in the US is for loans, somebody just put in different things and then they just like, oh, we never changed the gender, male or female. And of course it was, females were getting charged a lot more. But it turned out also teachers were getting charged a lot more. And so there was this really thing of like, wait, why that shouldn't be the case. How is that the case? Is it that your algorithm has, you know, deficiencies, or is it did you input that intentionally? And now you're into the regulatory space, and it's very hard to dig yourself out of that.
So India, I guess, has even more blue-collar jobs than US, right? And they'll probably be automated in the next 5 to 10 years, especially drivers if self-driving cars become perfected. So what are your thoughts on what we can do so that we don't forget about the people who are unemployed?
Great question. Thank you for asking it. The question of automation, and what I would encourage everyone is we often frame this as an AI question rather than an automation question. We really should be thinking about it, generalized automation. So there's a part of automation that I'm a big fan of where people are going to lose their jobs, and that is kids. I think kids should lose their jobs because they should be in school instead of working out, you know, on the fields or sewing a soccer ball or any of these things. Like, those jobs should not exist. It doesn't say, well, how do we address the people who also have jobs and are going to lose them? That includes, you know, bank tellers to, different type of machining where robots are going to replace things. The part there that I get concerned about is we're going to open up a huge territory of jobs, but there's also a portion that what happens to those where the jobs move away. One of the last things we did at the White House was we did release a report on artificial intelligence. So if you do a search for White House AI report, and that was largely led by Ed Felton, who drove that process. And one of the things that we realized is that the U.S. is really about to undergo a dramatic change. And the only thing that I think we can get ready for and we can try to do is make sure that we're educating everyone very aggressively to think about what that looks like. We also, people who are about to jump into new jobs in fields where they're going to get disrupted, we should divert them faster. Get them from taking those jobs, moving them to other areas so we get ready for that. And then pathways to the next type of job. We got to figure that out. And it's easy to say training and just train people. I think we got to think very creatively about what does that actually mean and how are we going to take care of that population. That is a wide open area for policy and technologists and everyone to start getting involved in now. And actually, we should have been getting involved in this much earlier. And I'll tell you, the person who was most concerned about this initially when we started this process at the White House was actually President Obama. He was the one saying, I don't think you guys understand AI. Go on. Which usually is, yes, Mr. President. But his point was he could see that the technologies and the way we are thinking about it and what the impacts to the broad base of America, because he's thinking about the people. He's putting people above the data. He's saying, look, I think you guys should think harder and take another look at this. When we did, we said, whoa, oh my gosh, this is actually really serious. Like, we better get on this. So we were late. President Obama was early on it. And so I think India is right to, or should be thinking about this now.
So we are seeing a lot of data scientists, creating small products or some kind of POC, but there are a lot of software products which are not either data-based or machine learning-based. So what's your opinion on the role of being a data scientist, being a part of that, software development process, which is not just data or machine learning-based? Because eventually that product is going to somewhere generate data.
Oh, thank you for asking. So I think what we often do is we think about data science as a siloed area. And I would like to think of it as a vertical that cuts across or horizontal that cuts across everything. So in the product process, one of the ways we did that at LinkedIn, because there was an existing structure, is we said, no, data is a full-blown product. It's a team, and it exists, and it is held accountable by the same metrics as everybody else, but we're building the product from the start, and we're building with other teams. We've seen increasing amounts where teams, and this is the way we structure this at Relate IQ, is that data science was central to everything that we did in product. And so the teams that I ran were the design teams, the product teams, the communications teams, the marketing team. All of that was tied together. And that was stemming from the belief that data has to be central to the core at the start. Other companies, there's a company called Stitch Fix, which is about to go through an IPO, and they have a great data scientist named Eric Colson, who actually, at the beginning of the Stitch Fix, has instituted data science across every single element. It's a clothing company, a kind of e-commerce kind of clothing company. The closest akin here in India would be Myntra. But the ability that when they've done this at the front has opened up new avenues of data and has also allowed very creative, new, novel things to come up. And really, really great things to happen. I'll tell you some people who've done it poorly is in the health wearable space, is that as people think about these products, they're not always thinking about the data scientists or what they could do. So they don't think about, well, should you also add one more sensor? Should you maybe have a different way to think about this? So now we're able to come up with more unique things or better products that we can go deliver. A really good data product is a product that facilitates an end goal through the use of data. It doesn't have to show data, but it facilitates an end goal through the use of data. And that's the big thing that we're seeing. When you start going to supermarkets soon, what will be happening is there is a data product and you don't even get to see it because it's the thing that's actually making sure the logistics and the supply chain is all working together. FedEx, DHL, these are data products at the end of the day. They are data companies. They may be sitting on technology that we don't give enough respect to, of logistic regression and linear programming and some of these classic technologies. But they are built from the premise of being data companies. And I think we'd be wise to think of it as a way you're espousing of saying, look, move it upstream at the very beginning to that whole process and make sure that opens up more territory rather than a data scientist being handed a bunch of things and saying, look, data scientists, work your magic. That's not how it works. That's actually a great recipe for a failure.
I think I'll just take one last question and I'll address it myself. So the question is that, as a community, so while we've got the thing started, we see the interest, but what would be 2 or 3 key things which you think we should be implementing as a community out here to promote the data science ecosystem much more than what it is?
So these are things that come to mind immediately from any community. And these aren't specific to the data science community because they're general for all communities. Is number one is you have to learn to trust each other more. We all have this attitude of, especially in startup ecosystems, of like, don't share my idea because somebody else will take it and rip it off.
Yeah.
Like every company I've been able to have a chance to work on, the number of people are like, I had that idea. I talk to people all the time like, I thought of eBay before eBay. I'm sure you did. But there's a reason there's an eBay. So you don't win because you had the idea.
Yeah.
You win because you got people bought into the idea and together you went together. The old adage, if you want to go fast, go alone. If you want to go far, go together. That is generally true. So learn to share and trust more together. Just having presentations as a community is really designed as an excuse for more people to hang out and talk and share and learn and build together and try things. So that would be 1. 2, figure out what are the hard problems and figure out how to talk about them and get together about how to work on them collectively. How did some of these companies like Cloudera and Kafka with Confluent and some Sumo Logic and all these things come together? These were all people who used to regularly hang out in data science, and we used to say, like, if only you could do this, I would buy that today. So we said, really? I'm like, yes, you got to go build that. And so that sort of attitude is what launched a large number of efforts, not only open source, but also companies. So I would encourage all of us to think more broadly. And then the final one is realize that the data science can be applied in really areas where you have no expertise. And so don't think of your community as just data science. Think of data engineering and other things. Design, as you've worked in marketing, other things. Open it up, make the table bigger. See that it's not just about producing analytics. That may be home base. It's like where you're strongest, but there's a lot more else that can happen.
Yeah, sure.
And then make sure you're doing the security and the ethics.
Yeah, be responsible. Okay. Thanks a lot, DJ, for taking this time out. I think it's wonderful to have you here and address the community. A small token of thanks, which I just pulled out. Just a small way to thank you.
Thank you very much.
Thank you.
Thank you.
Thanks
Good.
a lot.
Thank you very much.
Thank you.